Hello, hi, welcome and welcome back to Selenium Express. Let's just continue learning the Stream API right now, and in today's lesson, I'm going to be focusing pretty much into one thing. What I call the stateful or the stateless behavior of an intermediate operation that we perform in a Stream API. Well, so if you have actually came to this video, either you have already went through my last couple of videos and grabbed some understanding about the Stream API, or you already know a little bit of Stream API, just want to understand what this stateful or the stateless behavior of a intermediate function that we have in a Stream API. I'll have a deep dive into that. But so far what we understand that Stream, what is Stream? Stream is there to process a group of elements or a collection of elements. Stream is not a data structure, right? We have some source which may be an array, or it may be a collection, or it may be a generator function which generates some data. We need to have a data structure. What we can say is a source which has the data. Then Stream is just a pipeline where it is going to process those collection of data that we have in the source. So Stream is just a pipeline which is set to the source where the data will be flowing. We understand that. And actually, to make a Stream process the data, we have a lot of methods, right? We have methods like filter, we have methods like map, we have methods like for each. We have seen all these methods in the last session. But what we understand right now, we have two kind of methods or two kind of functions that we have in Stream API. One part of the methods, what we call the intermediate operation. So the types of the method that we have, like filters or map. Okay, we have seen those things. One type of methods are what we call terminal operations, like for each or collect, that we have seen in this particular video. But what we have realized, the streams are lazy. The intermediate operations, almost all intermediate operations are lazy in nature. That means if you're going to perform filter over a stream or map over a stream, it's actually not going to do anything. It's just going to return back a new stream by applying the filter on top of it, or by applying the map on top of the stream, on top of the given stream. But it has not actually processed the data. The data processing begins, or the stream basically triggered when we basically use a terminal operations. Terminal operations like for each. The method like for each, which basically triggers the stream. The terminal operations are eager, right? They basically triggers the stream and the data keep flowing. The filter method or the map method or the intermediate functions, they start doing their work, and then the for each method is basically produces a result or grabs the result. But now what we are trying to concentrate over here, we spoke about the intermediate operations. Let's say filter or map or blah, blah, blah. There are so many methods like that. Right now, we're going to be focusing on the intermediate operation, because the methods that we have seen so far, like a map method or a filter method, these methods are stateless in nature. Okay, so why I'm calling those methods as stateless, and what is this stateless, stateful kind of operations that we have in Stream API intermediate operations? What kind of operations that we have which are stateful or stateless? What exactly we mean by stateful or stateless even? That's something that we're going to be talking about in this particular video. So we are all set for the session right now, because we have the foundation fundamentals. We know what is Stream, how it works, how the data process, and we're going to be resuming right from here, right now. So first of all, let's just go back to our ID. The first thing that I'm going to be doing right now, let's say I'm going to create a stream. Okay, let's say I'm going to create a stream using the of method. Let's say to create a source, because I want to have some data in order to process them. Let's say I'm going to be having some data like this, 1, then 3, then 2, then 1. Sorry, 1 is there. Let's say 4, then 7, then 6, then 8, then 5, then 9. Okay, so let's say I have few elements over here. Okay, and you already know what the what this off method is going to give me. It is going to give me a stream over here, a stream of integer. This is the source. Now on top of this source, okay, what I can do on top of this stream, what I can do, I can perform some operation in order to process this data. Okay, let's say right now what I want to do, I want to sort all the elements that I have over here. Now to sort all these elements, I have a method here in Stream API, what I call sorted. Okay, there is a sorted function over here which does not take anything, and this can help me to sort all these integers that I have in natural order. Okay, let's say I want data like 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10. Okay, now I want all this data to be sorted in natural order. Now that work can be done by the sorted, and sorted function is what is, if I can hover on this, is again an intermediate operation, but it's saying it's a stateful intermediate operation. In the last video, I think we were doing something on limit, and it was also saying limit was a stateful short circuiting intermediate operation. We'll also come into that. But one new thing we are getting, it is stateful intermediate operation. It's an intermediate operation. That means it is going to sort everything. Then if I, like intermediate operation does what? If I'm going to do control option V and try to handle the return type of this is going to get me a stream again. As you can see, it is going to get me a stream of integer again. And I'm sure that this might have been sorted. If I'm going to go over here to this, let's say I'm going to write sorted stream. It's going to get me a pipeline where the data will be processed one by one. And I'm going to say sorted stream, and I'm going to print out everything. Let's say for each, and I'm going to take a number, and I'm going to print out that number. Let's say s out number. And I'm sure right now this number will be printed in sorted order. So if I'm going to run this, let me just run this one. Run this class. I'm sure I'm going to get everything in sorted manner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So everything working fine. So we understood that the sorted is another intermediate function. Obviously, if you're going to, if you want to chain it also, you can chain it like this with this, and you can, this is what people say fusion. Okay, we are doing a fusion with our the different methods that we have with our Stream API, right? And this works good. But what exactly is happening over here? Why we are saying the sorted is a stateful operation, and what do we mean by this sorted is a stateful operation? If I'm going to hover on this, it's saying sorted is a stateful intermediate operation. So this meaning stateful, what I mean by that, the sorted is actually having a kind of memory, okay? Because in order to sort every element, let's say this, if the sorting needs to happen over here, the sorted method need to grab all these elements. So they said in Stream API, the data will be flowing one by one, right? So every data need to be processed till the sorted method over here, and then the sorted method can actually see all this data, then can sort it, then can process it to the for each loop. Okay, what I mean by that, okay, because the things are going to happen a little bit in a different way. But I think the sorted method, the work is, you understand the work, like how it works. It's pretty simple. You are calling sorted, and it is doing the sort like this, right? There is nothing to worry about it. I can do something like this, like let's say if I'm going to do control V, and let's say if you have some bunch of strings like this, and if I'm going to print all the strings that I have over here, then obviously it is going to sort all the strings over here. First Avi will come, then maybe Joe will come, then Rakesh will come, then Jia will come. It will sort them according to the natural sorting order, like in a dictionary, right? I have Avi, Joe, Rakesh, Jia. You understand the sorted function is working fine. Working wise, we're okay. We understand what this method does actually. It's basically sorting our elements based on the natural order over here. Now let's just go a little bit of in depth and let's just try to understand what is actually happening behind the scene. How the order of execution is going on whenever we're processing the elements over here. And it's a very important fundamental that I want it to be a fit into your mind right now in the initial stage only. So let's just try to deal with this bunch of strings that we are trying to sort over here. Let me just comment out the other things that we have written, and let me just get it to somewhere to here. And I want to have some white space here so that I can only focus on this lines of code. Now, what I'm going to do here, I'm going to taking each string over here, sorting it and printing it over here. That's how the stream pipeline goes, and that's what we understand. The stream basically process one by one element, and one by one element is basically keeps on flowing through the stream. So what we understand right now, GR should come to sorted, sorted should do something and sort the GR and give it to the for each, something like that. But don't you think it's the impossible thing for the sort to sort by looking into one element? Let's say GR is coming to here to the sorted method. Now the sorted method should give that element to for each right now to print. Then GR will be printed at first. That should not happen. Obvi should be the first element that should be printed over here. So somehow the sorted method is remembering all the elements which are coming towards it, right? Let's say sorted method knows first it will grab all the elements from the source stream. Let's say here from the source, it is going to grab everything. Let's say, hey, I want to get all the elements right now. So to the sorted method, every elements to be feeded, like Rakesh will be fed to this, Joe will be fed to this, and Avi will be given to this, right? Now the sorted method first will grab all the elements right now, and then it will try to sort them, and then it will try to emit the data to the for each method in order to consume. So here, that's why we're saying the sorted method is a stateful operation. The sorted method has a kind of memory. It buffers the data. It has kind of a memory. Buffers means it stores the data. It might have some kind of a temporary memory where it is grabbing its elements, storing it inside them, sorting it, and then emitting the data to the for each method. And the for each method is printing all the data in a sorted manner, right? So here, don't think like the flow will go like this. First GR will come to here, and then GR will be printed over here. Then Rakesh will come to here, then Rakesh will be printed over here. Then Joe will come to here, and then it will be printed over here. Then Avi will come to here and will be printed over here. And then the sorting happens and some magic is happening. No. Here the data is not coming one by one, like one data is coming here, then one data is coming here. The sorted method is not processing the data one by one over here. The sorted method is grabbing everything. It is storing everything inside it and then processing it once the sorting is done. I'm going to be proving it in a minute. Okay, that's why we are saying the sorted method is a stateful intermediate operation. It's a stateful. It remembers the state of the object. It's remember like the state. It's remember each elements which basically it processes, right? It's remembering everything. That's why it is stateful. What is stateless? Like a filter. For an example, let's just have a filter condition over here. Okay, I'm going to say dot filter here. Okay, I'm going to have a filter. Let's say in this filter, I want to have some kind of a logic, filtration logic. Let's say I want to check each of this name string that I have. I'm going to say each of this name string that I have. I'm going to check if this name, all the names are greater than 2 characters or 3 characters, and only if it is greater than 2 or 3 characters. Let's say greater than 2 characters. I'm going to check right now. Okay, I'm going to check. I'm going to say a name string, and I'm going to return what? If I'm going to check if the name string dot length is greater than 2. Okay, this is my condition that I have right now. Okay, so I'm gonna take each of the string over here, like Rakesh will come to here, Joe will come to here, and I'm gonna check if their length is greater than 2, and in case yes, then I'm gonna be filtering it and processing it to the next step. You guys know how the things goes over here. But now I want to see this thing. Okay, let's say what I'm gonna do. I'm going to have some log here. Okay, in the filter method right now, this is something that I'm returning. I'm going to wrap it off inside a curly brace. I'm going to give a semicolon over here, and this is what I'm going to return, and I'm going to have a enter over here, something like this. Okay, in the filter I'm doing this thing, but I'm going to have a s out over here. Let's say filter method, this is a log from the filter method. Let's say applying filter on let's say name, and I'm actually gonna print the name. Okay, I'm gonna print the name string which is coming to me. I'm gonna say name string. Okay, let's say this is some mess out statement that I have written over here. Okay, just after filter happens, and the elements will be given to the sorted. After the sorted happens, I'm gonna have another pick. Okay, let's say I'm gonna take each of the name which has been sorted right now. Let's say name. Okay, and I'm gonna say s out. Let's say sorting done for name, and I'm gonna give the name over here. I'm gonna try to print the name over here. That's something that I want to do. Let's say I have set up a pipeline, something like this. You understand like what's happening over here? I think it's pretty straightforward, isn't it? We are trying to pick each of the name, trying to do the filter. Then we are giving it a sorted method. Once the sorted happens, I'm going to print the sorted element to the console. Let's say sorting done for the name something. Then I'm actually printing something over here in the for each loop. Okay, so let's just see how basically the flow goes over here. If I'm going to run this, okay, don't freak out. Okay, look at this, how the things happened over here. Okay, this is what the log says. Now if I'm gonna minimize a little bit, I'm gonna just zoom out a little bit. Okay, I think you can see everything on the screen. Now look at this. Now we got GR as a first element, then the filter applied, then we should be getting filter applying filter on the name GR. Filter is a log from the filter, applying filter on the name GR. Works good. Okay, then this name GR should be given to sorted, right? That should be the next step, right? And then if we're gonna go with a traditional flow, we should have the pick printed, okay? Like sorting done for the name GR, but it doesn't happen like that, right? Now the next line over here is again the next time the filter executes. And it basically takes another elements from the stream pipeline or from the stream source and putting it inside the filter, and the log for that is over here. Filter, applying filter on the name Rakesh. There you go, applying filter on the name Rakesh. Then it is given to sorted, and I'm expecting that I should get another line sorting done for the name Rakesh, but I don't have that log over here. So it looks like all the filter operations are getting done first. Okay, so GI is taken, given to filter. Rakesh is taken, given to filter. For Joe, filter is applied, given to sorted. For Avi, filter is applied, given to sorted. Like for every elements, filter are getting applied and given to sorted right now at first. Okay, so that's why you're getting all this line printed on the console. Once the sorted grabs every element which is processes through the filter, right? Now the sorted is doing what? It is started processing the data. I told you sorted is a stateful operation. It's stateful. It's stateful. It need to remember all the elements. It need to see every individual elements in order to process them. And that's the proof of that. Once the filter emits all the data to the sorted, now sorted understood that, okay, now from the stream, now from the source, we grabbed everything. Now the sorted will be going into action. Now you can see it started giving one element, but first element it has given right now is Avi, because it already have all the elements, it's sorted everything. Now it's pick this element which was in last right now. Okay, given that to pick is just printing it, sorting down for the name Avi, and then for it is basically printing Avi. Now the sorted is giving the second element right now. It started emitting the data right now. Sorted is started emitting the data. Previously it was just consuming the data from the other stream that we are applied to, which is the filter stream. From here it was consuming the data. Right now it started emitting the data, started giving the data one by one. First it has given Avi, and we are printing it. Then I think it is giving Joe right now, started giving the next element Joe, pick is printing it, and pick is printing it, then we are printing it again with the for each. This way is saying sorting done for Joe and Joe. Next sorted is giving, let's say, Rakesh. It is giving pick is printing it, sorting done for Rakesh and printing Rakesh. At last sorted is emitting Jia and pick is just getting it, and then for is just printing it. And I can see the couple of lines over here. So the sorted method over here, being a stateful method, is basically breaking a stream pipeline into two parts, right? Because it need to remember the state. It cannot directly start emitting the data one by one. It need to see all the elements, right? But the filter, if you're gonna hover on this, it's just a intermediate operation. It's not a stateful intermediate operation. It's a stateless intermediate operation. Filter does not have to determine the state. Filter does not need to buffer the data. Filter doesn't need to store the data. Filter doesn't need to know about the individual element it is processing. For an example, filter is processing the first data Jia, right? Now the filter doesn't have to remember that it has processed a data called Jia. It has processed a name called Jia. It just applied the filters, giving it to the sorted, then forgets about it. So each individual element which is going through the filter, that is being forgotten by filter. Filter is not tracking their state. This is just like Ghazni. You have watched that movie Ghazni in South movie, and some Bollywood movies also there, Ghazni, right? That guy doesn't remember anything. Once something, let's say it is, I'm just looking into this iPad right now, then I'm going to look at over here, then I forget about I have looked into the iPad. So the filter does not retain the state at all, right? That's why it is a stateless operation, right? But the sorted is basically a stateful operation, because as the name suggests, in order to do the sorting, we need to grab the elements and we need to see them first. Okay, I think this makes sense, and you understood how basically the flow happens over here. First, this stateless operation took place. It processes everything to the sorted. Then once sorted grabs everything, it started emitting the data again to the pick and then to the for each, right? So till this one part, till this another part. This is how the flow is going. If you're going to look inside the presentation a little bit, I'm going to come into this documentation, and I'm going to show you what we have over here. As you can see right now in the documentation also, they have, this is the stream documentation, and if you can see over here, they also have written over here, okay, intermediate operations are further divided into stateless and stateful operations. Okay, we understood about it. Stateless operations such as filter and map retain no state from the previously seen elements when processing a new element, right? Each element can be processed independently of operations on the other elements, right? So there is no relation between the previous element the filter has processed with the current element the filter is processing. It doesn't have to look the previous element to do something with the current element, right? That's why the filter is stateless, right? The stateful operations such as distinct, we haven't spoke about distinct, but we spoke about this one. The stateful operations, just like sorted, may incorporate the state from previously seen elements when processing the new elements. And that's what they basically clarify over here in this paragraph. Let's say they are saying the stateful operations may need to process the entire input before producing the result. For an example, one cannot produce any result from sorting a stream until one has seen all the elements inside the stream. Okay, so we understood that the stateful operation may need to process the entire input before producing a result, just like sort. It needs to process entire input first before it produces the result. So it's happened something like this. Okay. Okay, I think things are going good and you started understanding how this sorted function works a little bit, right? Let's just go into a different class right now. Let's just create a class here right now called test7, okay? Let me maximize this and have a main method inside it. I'm gonna ask you a question right now, okay? Let's just try to set up a stream source right now, and I'll try to basically generate a infinite stream. You already have seen the generator or the generate method, which basically helps me to generate a infinite stream. Just like that, to have the infinite stream over here, I can also take another method. Another method can help me. I think it's there in the stream API. Instead of generate method, I can take another method to generate an infinite stream. I just want to create a stream source. Just want to use this method so that you are also aware about this method. So there is a method here, as you can see, it's called Iterate. Okay, take this Iterate method, and it's going to take a couple of things here. I'm going to use this first one over here. The first parameter is going to take a seed. The second parameter is going to take a unary operator. Okay, what actually is this one? Okay, the first parameter is going to take a seed. Let's say my seed is 0. I want to start with 0. And then the second parameter is basically going to take a function. Okay, it's something like a function. It's like it's going to take a unary operator, but this unary operator is just like a function. I'll tell you why. The second parameter is going to be a unary function, and obviously it's again a functional interface. I'm going to hit enter, so it is going to override the function that I have inside that interface, right? That's called the apply method. If I'm going to go to this unary operator, which is a functional interface, you can see it has a method. It basically doesn't have any method. It's basically extends to function, right? Unary operator is something like a function only. The only difference here in the unary operator, let's say in the function, if you can see, we have an apply method, right? In the function, you can take any kind of input. Let's say this t can be anything. You can take any kind of input, and the output will be any type. Let's say I'm going to take a string. I can give you the output as integer. I can take a string over here and can return an integer. I can take a double over here and can return a string. Okay, the input can be anything, the output can be anything. But the unary operator is a special function. Okay, it's a special function. You can even see represents an operation on a single operand that produces a result of the same type as this operand, right? This is a specialization of function for the case where the operand and the result are of the same type. So if you're going to see the method that I've overridden over here inside this iterate, over here I have the unary operator and I am overriding the function that I have inside it. You can see it takes an input. Okay, in this case I am operating over this 0 and 0 in integer. So I'm going to take this 0 over here, which is an integer, and the return type is also going to be integer again. So whatever you're going to take, I'm going to take an integer. The output is also going to be the same type as the input, right? So in the function, this can be anything, this can be anything. But in unary operator, whatever the type you're going to be putting over here, let's say it's a string, then it's going to be a string. If it's an integer, this is going to be an integer, right? So now inside this iterate method, I'm taking a unary operator, taking the seed as 0. That 0 I'll be accepting over here, and I'll be returning what? Every time I'll be doing, let's say, integer plus 1. Okay, let's say first it will be 0. I'm going to accept the 0, then do 0 plus 1. It will be 1. Okay, then I'm going to take 1, then I'm going to accept 1, then it will be 1 plus 1. It will be 2. Then it will be the seed will be 2. I'm going to accept 2 and do 2 plus 1. It will be 3. Right, something like that. I'll be keep on iterating and will be keep on producing the result based on this, right? So just remember that this is another special type of functional interface that I have, which is something a specialization of function, the unary operator, which I am accepting as the second parameter. Okay, so the end goal here is the iterate method is going to give me a infinite stream. Okay, so if we're going to do Control Option V over here, right over here, you can see it is going to get you a stream of integers, something like this. Okay, something like this. It's going to be a stream of integer. But remember that this is an infinite loop. It will be keep on loop. If I'm going to do stream of integer dot let's say for each, and let's say I'm gonna take every integer over here and I'm gonna be printing it out. Let's say integer. Okay, then what will happen? Then it will be keep on iterating and keep on giving me elements, and the for each is going to keep on printing all those elements. Let me run this. Okay, and what you can see here, a infinite stream over here. Okay, we just keep on going. Let me stop this. Okay, let me stop this over here. Come on, man. Okay, so you can see these are just the numbers that I have over here, which will be keep on doing plus over here. Okay, let's say if I'm going to have a condition, let's say I'm going to do a fusion over here on top of this iterate. First of all, on top of this iterate, I'm going to do a chaining like this with my for each over here. Okay, right over here I have the for each. Okay, now let's say over here I'm going to have a filter. Okay, and I'm going to say I only want the element. I want to take the integer. Let's say I'm going to take the integer and I'm going to have a check. Let's say if the integer is less than let's say 20. I only want those integers which are less than 20, right? Then what will happen? So if I'm going to run this, okay, so I have elements till 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 20, right? Till 19, because I'm checking this condition is 20. But you can see it's a never-ending loop. It's still running, right? This is keep on producing. The filter is keep on checking, printing the element. But right now you can see once the once that numbers that we have for the positive thing is over, right now it started iterating over the negative thing and keep on producing those elements because those are less than 20, right? I think this is making sense to you. So if you want to have a break on this infinite stream, I can have something called a limit, right? Again, this limit function is a stateful operation. Just remember that. I can give limit over here, let's say 20. Okay, if I'm going to give limit over here, let's say 20, if I'm going to run this, then only I'm going to have 20 elements, or let's say 19 elements, because it started from 0 to 19 is around 20 elements. Then you can see after limit has been exceeded, for each has done its work. It's taken the every elements and printed it. Then you can see the limit is short circuiting the pipeline over here and is terminating the pipeline. That's why you can see the limit is just short circuiting stateful intermediate operation. I have added the limit over here. That means I want only 20 elements from this stream that this iterate method is going to give. This is giving me an infinite stream, but I want to get finite result. I want to get 20 results only. That's why I have added this limit. After it reaches 20, it is basically terminating the program, right? It's terminating the stream itself because we already have achieved that thing. What do we want to achieve? That's why you can see the stop sign is not on right now. You can see the process finished with exit code 0. That means it just has been exited normally, right? So the stop symbol is not enabled right now. So my program is no longer running. So the limit is a short circuiting operation. That means once the limit has been exceeded, it is terminating the pipeline completely, right? So the data are not flowing anymore in the pipeline. The pipeline is closed, right? So I think this thing makes sense. Well, so for now, just remember that limit is a short circuiting. It will terminate the pipeline immediately once that limit has been reached, and it's a stateful. It's basically remember, or it knows all the elements which is getting processed through it. Okay. Understand this much. No debugging is required for now. We're going into that in a little more time. I think this is clear. I'm going to give you another example. Tell me what will happen in this case. Let's say I have a lot of elements coming over here. It's an infinite loop. A lot of elements will be keep on coming. I have a question over here. Let's say I'll call the sorted method here. Okay, for example, sorted. Let's say whatever. Right now, obviously, the elements are coming like 0, 1, 2, 3, 4, 5, 6. it will be keep on iterating and keep on generating the elements, and we're starting from 0. So obviously those are already sorted. But let's say I'm calling the sorted method on top of it. In case it is the source is going to give some unsorted value, the sorted can sort it, and then the for each method will be invoked. Okay. If I'm going to run this, what is going to happen? Can you tell me? In this case, the sorted method will work in a different way. As I said, the sorted method is basically going to sort all the elements. So to sort all the elements, it needs to first grab all the elements that we have inside the stream, inside the source stream. But here the source is an infinite stream. It's a this one is going to generate me an infinite stream. It will be keep on iterating. It's going to keep on giving me results, right? So the sorted method will expect that this iterate will be keep on feeding every element that it has, until then it will be keep on waiting. It will not process any elements to the for each till it got every element, because sorted is a kind of stateful operation which needs all the elements. It needs to see all the elements in order to process it. So it will be keep on waiting to grab every elements, but the iterate will be keep on producing. So it will be so the sorted will be keep on waiting right now. You can see there is nothing in the console. You have this stop button here. So the program is keep on running right now, and we have ended up having nothing in the console right now. But after some time, obviously it will go out of memory. The Java heap goes out of the space, because iterate basically keep on iterating, but the sorted is keep on storing those elements, and some point of time it goes out of memory, right? So we got java.lang of out of memory exception. Okay, I think you understand the way this thing works. Okay, and this happens for the test 7 Java 14th line for the for each, right? And I think you understand this use case where you don't have to use this sorted, because the sorted functionality can be different if it is an infinite stream. Okay, so don't use sorted when it is an infinite stream. Obviously, this kind of stream, we don't use it in real time. We obviously have finite stream all the time. We have a collection of data, and those are finite number of data. But this kind of method like iterate or generate basically generate infinite stream. Okay, so don't use sorted over there. Okay, got it. The next thing, okay, so let me just remove everything. I will show you some different method. I'll show you another stateful short circuiting function, okay, like takeWhile. There is a method called takeWhile. There is an intermediate method called takeWhile. I'll show you that. For an example, imagine I have a source stream. Let's say stream.off. Okay, imagine I have a source stream. Okay, now here imagine I want to have a filter. Okay, for an example, I'll have a filter over here. In the filter, let's say I'm going to take an integer. Okay, simple thing again, integer, and I'm going to check if the integer is less than 8. Okay, I have this integer, so it is going to process every integer where the integer is less than 8. Now my question is, if I'm going to do let's say if I'm going to do a for each, and what happens over here? Okay, I have given a dot. I'll give this right now. Okay, you know what is going to happen. It is going to print all the elements which are less than 8. Okay, which is good. Now what I want, let's say every elements that I have over here. Okay, let's say I have elements which will be processed one by one. Let's say 1 will be processed, 2 will be processed, till 7 everything will be processed. Now every element which is getting processed, I want to find the square root of it. So how can I do that? I want to take an input and I want to convert it to the square root of it. So what I can do, I can use the map function so that I can transform the input number. Let's say I'm going to take an input right now. Let's say I'm going to take a number here, okay, and I'm going to be processing it. I'm going to do number into number right now, okay. So basically I'm taking each of the number and I'm finding the square root of it, and then I'm going to take that number and I'm going to print it over here. I think this makes sense, right? So if I'm going to run this, if I'm going to do right click, run this, then what is going to happen? And obviously you're going to be finding for the 1, the square root is 1, okay. Then 2 will be processed through the filter, the condition match goes to the map, then 2 into 2 it will be 4, okay. Then we'll be printing it finally with the for each loop. Then 3 will be processed, then filter condition matched, it will be 3 into 3 equal to 9, then printing 9 over here. Like that it will be keep on going and things are working fine, okay. Just like filter, I have used over here for a condition check, right? I have another method called takeWhile, which does the exact thing as filter, okay, but little bit in a different way, okay. To make us understand how the method, so instead of filter, I'm going to use something called takeWhile, okay. It is another method that I have, which I can use in instead of filter right now. Okay, it does the exact similar kind of work. But what is the difference here and why I'm talking about this takeWhile method? Because as we are talking about stateful short circuiting operation, I'm going to show you another short circuiting operation so that you can understand this word short circuiting. What does it mean? For an example, guys, in filter, for an example, you know how basically the flow goes over here. Okay, I'll show you one thing. For an example, so I have a couple of logs right now, okay, and now you know like what is going to happen if I'm going to run this. So the way the processing happens, you know that first 1 will be picked, goes through the filter, if it passes it, goes to the map, then the for each will be applied. Then 2 will be picked, goes to the filter, condition will match or not based upon that. If it matches, goes to the map, then this thing will happen, then the for each will be performed. You know like the way it works, right? So if you're going to see here, you can see the way it works, right? First the filter, then the map, then the for each. It's printing 1. Then first the filter, then the map, then the for each is printing the square root of 2, which is 4. Then processing the number 3, mapping the number 3, and the result is 9. Then processing the number 4, mapping the number 4, then it is 16, right? So till 7, I think all my condition will match. Till 7, all my condition will match till here, okay? But what happens in the 8th element? Let's just go to the 8th one. And as you can see on the 8th one, we only have the filter executed, right? Because for the 8th one, when it goes to the filter, this condition doesn't match. And if it doesn't match, it has never given to the map and the for each method never executed. And same as number 9 also been picked, that didn't match. That's why it didn't go over here to the map. Okay, then the for each will again check, okay, do I have any other elements? Then we have 9, then we have 10. Everything goes to the filter but cannot pass through the filter and cannot reach to the map. You understand that flow, right? But notice this lines over here. This last 3 filter logs for 8, 9, 10. So here, filter is basically passing each element through it from the source, and it's basically applying the condition whether the condition is matching. Okay, here the condition does not match for the 8, does not match for the 9, does not match for the 10, and it keeps on checking all those elements that we have over here. Even if we have 11 over here, still it is going to check whether for 11th the condition match or not. And for 11th also the condition didn't match, so it didn't pass it to the map function. You understand that? Now, like that, we also have a method called takeWhile. Okay, it also takes a predicate exactly like the filter, but the filter was a stateless function. It doesn't care about the values that you are passing, that we are passing through the filter, right? It doesn't track those values. But takeWhile is a function which basically tracks whether the condition matches or not, right? It does the exact same thing as filter. If I'm gonna hover on this, it's a short circuiting stateful intermediate operation, exactly like the filter. It's an intermediate operation, but it is stateful and short circuiting. So what it does right now, okay, we'll see this. What this takeWhile method does, it is going to take 1, check if the condition matches or not. if matches, it goes to the number 2. Okay, and like that, let's say first it's going to take 1, check for the condition, passes it to the map, then printing it. Okay, number 2, take this one, passing it to this, then the map function is doing its work, then it's going to the for each. Like 3 also matches, goes to the map, for each will just print the element. Like that, the takeWhile will also take each of the element and will apply this condition and check whether that is matching or not. And as long as it is matching, it is going to keep on printing the element. But the moment it doesn't match, okay, it will short circuit the pipeline there only. It doesn't check any further. Let's say for an example, in 8, okay, it is going to have a check over here and the condition fails over here. Right here only, it will short circuit the pipeline. Okay, short circuiting means it is going to terminate the pipeline. Short circuiting means think like first let me run this. If I'm going to run this, you're going to see, okay, now for one, for the one, filtering is happening, mapping is happening, for each is happening. For 2, condition match for the filter, map is happening, the for each is happening. 3 also, the things are happening. 4 also, the things are happening. What about for the 8th? You can see for the 8th, the filter is not actually the filter, the takeWhile. It's basically the takeWhile. Let me put it over here, takeWhile. The takeWhile is basically checking the condition. But as 8 is less than 8, this is false. Okay, it's basically terminate or short circuit the pipeline there only. Okay, so you can see 8 has not been processed to the map, but it didn't check the next element right now. It didn't pick the 9th element, and it didn't basically check the condition on top of it. And for the 10th and 11th also, it didn't check the condition for it. So right when it fails, right when the condition fails, is basically doing the short circuit. Okay, think like there is a MCB. Okay, it's just turning off the switch over there and stops the pipeline to flow the data anymore. Okay, so the data is no more flowing because it has a kind of switch. It's short circuiting it and turning off the switch. So the current is not going to flow from one device to another. If you're gonna switch off the MCB, just like that, it is switch off that MCB over here for the data pipeline. The takeWhile method is short circuiting the pipeline, and the data is no longer flowing over here. I hope this makes sense. Now I think this things make sense, right? The way it works. So the takeWhile is a stateful operation. The takeWhile is tracking every element that the takeWhile is processing. It is basically tracking the elements over here. It is tracking the element for 1, it's tracking the element for 2, 3, 4, 5, 6, 7, 8, 9. It checks like every element is processes through it. That's why it is stateful. Okay, that's why it is stateful, and also is short circuiting the moment it finds no, this is not this element doesn't match the condition. It's short circuiting it. Exactly same like the filter, but filter is stateless, it is stateful. Filter is not short circuited, and this is a short circuiting stateful and intermediate operation. I think this makes sense. Well, I'll tell a little bit about a takeWhile more, like the execution flow. Right now, don't think about every element will be given to the takeWhile first, and as the takeWhile is a stateful intermediate operation, it need to consume every element, it need to see every element, then it will process it to map. Don't think like that. That is not happening over here, because as per the documentation, if you're going to go to the documentation, you can clearly see. You can see stateful operation may need to process the entire input before processing the result, like the sorted one. Okay, like sorting the stream. But here we are not sorting the stream. Like we have to take every stream, then we need to see every object in the stream, then we can sort it. No, here I'm just taking every element and it just knows about it. Maybe it's buffering the data somewhere, and then it's processing the element to the next step. And this keeps on going till the condition fails, right? I'm going to give you another example for this, okay? I think this will make more sense to you. So I'm going to comment this out, okay? Let's say I have a stream of strings, okay? Joe, Robin, Vilas, Jay, and Krishna, okay? And let's say I am going to have a takeWhile, okay? And let's say here I'm going to take every string that I have in the pipeline, and I'm going to check if the string dot length is greater than 3. Okay, then only I need to process it. Okay, and then I'm gonna print out every element. Okay, I'm gonna say I'm gonna take str and I'm gonna print it out over here. Okay, something like this. Now tell me what will be there in the on the console, right? What data I will be getting on the console right now? Can you think about it? So first Joe will be taken and the condition will be matched. Okay, here the condition is matching or not matching. Joe is the string and it's greater than 3. It's greater than 3. Is true or false? Is true or false? It's false, right? If it is false, then the takeWhile will be straight away terminating the loop over here. So if I'm gonna run this, you can see nothing in the console because the first condition only does not match. Okay, and what about if I'm gonna say if it is greater than, if I'm gonna change the condition to 2, then this matches, right? Then I think this condition match, the next one will also match, the third one will also match, this will also match, this will also match. We got everything, right? But let's say the moment, let's say I have another string over here, let's say Joe, like couple of letter, let's say couple of character here, and then I have a normal string called Rakesh, then I have another string called, let's say Kiran, then what will happen? Now over here, right here in the Joe, the condition fails. So the takeWhile will straight away terminate and short circuit the pipeline. Okay, you can see till Krishna it is printing, but right when it is Joe, the condition does not match, so it's just terminating and short circuiting the loop over here. Okay, understood? Alright, so let's just see some more stateful intermediate operations right now, and then we'll just talk about something really interesting. But I want you to see this methods that we have over here. I'm going to create a class called takeState. Okay, let's say we have a source stream. I'm going to go to the take7 and going to copy this. Okay, and I'm going to have this source over here. I'm going to have a main method, and I'm going to minimize this, expand it, and I'm going to paste it over here. Okay, let's say we have a source stream over here right now. Now what I want to do, I want to print obviously my source, but let's say here I have a requirement. I want to print everything, but I want to skip the first 3 elements that I have in the stream pipe that I have in the stream source. Then what I can do, I can have a function here called skip, right? And if I give the element that I want to skip, let's say I want to skip the first 3 elements over here. Okay, then what will happen? This will be skipped, this will be skipped, this will be skipped. Now it will be start printing from here, J, Krishna, Joe, Rakesh, and Kiran. So if I'm going to run this, okay, you can see it is printing from J, Krishna, Joe, Rakesh, and Kiran. So first 3 elements are getting skipped. If I'm going to hover on the skip again, skip is a stateful intermediate operation. For now you understand, skip is tracking every element that is processing right now, and after skipping the first 3 only, then it start emitting the data to the for each. Okay, think about it for now. Okay, it is skipping the first 3 data right over here. It started emitting from J, the skip started emitting, okay, J, Krishna, then Rakesh, then Kiran, start giving the data to for each. Okay, understand this much for now. Again, we're going to deep dive into it. We have some method. Let's say we also have a distinct method. For example, distinct is again a another stateful I think intermediate operation. If I'm going to hover on this, distinct is again a stateful intermediate operation. And what distinct does, you already can understand from the name only. It basically gives you distinct number of data, right? For example, here I have a Vilash, okay, and here nothing is getting repeated. But let's say if I have couple of string named Kiran, okay, I have another string over here called Vilash, okay, I have another string over here, let's say J, okay, then I have duplicates here, J, I have duplicates here Vilash, I have duplicates here Kiran. So if I'm gonna run this, okay, it will only give you distinct number of data. It gives you data like Joe, Robin, Vilash, J, Krishna, Joe, Rakesh, Kiran. Okay, this is Joe and this is Joe. Okay, spellings are different. So Vilash has been printed for 1 time, so only one Vilash has been processed from the distinct. Only one keyrun has been processed from the distinct, right? The distinct is a kind of operation that you can do over a stream if you want to only get distinct or the unique element from the pipeline. So we understood about the distinct method, we understood about the skip method, we understood about the takeWhile method, we understood about the limit method, we understood about the sorted method, and all these methods are the stateful methods, which basically retain the state of the element that it is trying to process, right? Kind of makes sense, okay? Now the question is, all right, why these methods are retaining state? Okay, for an example, the limit method. For an example, the takeWhile method. Why it is retaining the state? If I go to the test 7 right now, I told you about the takeWhile method. The takeWhile method job is very similar as the filter. It's basically going to check some condition. If Joe will goes through this, it is going to check the condition of the Joe. If let's say if that fails, it is going to short circuit it immediately. Okay, but the question is why it need to know each object that it is processing, because this is a stateful operation. Okay, for sorting I can understand. Sorting I can understand. If I need to sort all the elements, I need to know about the state of each element. I know about every elements that I need to process, I need to sort, then only I can do the sorting, right? So the sorting method, I pretty much understand that it grabs every element, waits till it basically grabs every element from the source, then it starts sorting. But for the takeWhile, why it is needed? Why the takeWhile needs to know every element it is processing, right? Don't you think like this? Okay, let's say Joe right now it is getting processed through the takeWhile method. Now the condition fails for Joe. Yes, straight away it can terminate, right? Why it needs to know Krishna, why it needs to know about J element, why it needs to know about a Vilas element, why this takeWhile needs to know about the Robin element, why the takeWhile needs to know every element that it has processed before. What is the need of it? People have questions like this, right? Because I told you the takeWhile need to remember the state of every object that is processing. But looking into the condition that we are making, we can think like when the condition fails, it can straight away terminate. Okay, what is the need of remembering the elements that it has already processed, right? It's a valid question. To make you understand this, I'm gonna give you an example of parallel stream. I'm going to bring this topic of parallel stream because right now what we're dealing with is all sequential stream. Whatever we're dealing with right now is sequential stream. Okay, sequential stream means like there is only one thread is involved. In our case, there is only main thread is involved, which is basically doing all the stream work that we're giving. Okay, but in real time, we can also have parallel stream where many threads can basically act upon of your stream. Let's say we have this source, okay? Now only one thread is processing every element. Let's say Joe, Rabin, Vilas, Jay, Krishna, whatever elements. Only one thread is there that is basically doing the work of, applying this condition and printing everything, right? But what I'll tell, like instead of one thread, if I'll give this task to 5 different threads, one thread will take care of Joe, Robin, and Vilas, and it will apply the condition and do the for each. One thread will take these 3 elements, will process these 3 elements by using this function. Another thread will basically do this thing. Okay, it's like one thread is basically processing each elements and finding the result for me. And 3 threads at a time will do the exact same work. One thread will basically check this 3 things. Another thread will check, let's say, these 3 things. Another thread will check these 3 things. Then my work can be done faster, right? By using parallel stream. Okay, let's just learn how it works a little bit and how the parallel stream basically impacts the performance. Let's just learn a little bit, and then we'll come back to the question again and we'll explore a little bit. Okay, but now let's just see how the parallel stream works, just for the foundation sake.